All right, can you hear me?
Yep.
Good. I don't know why we have trouble with that on this particular version. Okay, where are we? We're here on March 3rd. Quiz due, lab stuff is due tomorrow for lab 6. And Friday we'll do discussion about requirements and test cases on Friday. Okay, so all we're doing today and is lots of demos. And I want to demo, whoops, come on. I'm getting help from Zoom. Let's do show line. I didn't follow my form of making all these things attributes here when I refactored the code from the Yang text. This is pretty much straight from the, I believe it's pretty much straight from the Yang text. Lines are different graphical elements, as you would expect. It's just what it is. It's a line. And if you look on line 24 there in the code, it says line 1 equals new line 10, 50, 3, 90, 50. What do you guess those 4 numbers are telling you?
Probably like length, width, X location, and Y location.
Yeah, right. So a line is made up of 2 points. So the first 2 are the XY coordinates of the first point, and the 3, 90, 50 are the XY locations of the second. So what we should see is a line going from 10, 50 to 3, 90, 50. Remember, X goes from left to right on the screen, and Y goes from the upper left-hand corner down. So it should be 50 pixels down from the top and going from 10 to 390 pixels across the screen. And the second one is at an angle, so it starts at 40, 70 and goes to 250, 280. So the X dimensions are from 40 to 250. The Y dimensions are from 70 to 280. And as always, build your nodes, build the pane, add the nodes to the pane, add the pane to the scene, and then scene to the stage and show. So let's see, I've got all this from the previous. Ta-da! Exactly what we thought we'd see. Where would you use this? Okay, so several people are making games that are mazes, and my question is always, how are you going to represent your maze in data form? And one way you can do this is make the walls of the maze with lines. That may or may not be a good way to go. For platform games, I ask, how are you going to represent your platforms in data form? And the platforms almost certainly should be a line on the screen. That's a great simple way to throw a platform on the screen. So you would have a data that says an array of platforms, and they all start at XY location and end at XY location. And then to draw it on the screen, all you do is go get those values and make lines that match the beginning and end XY locations of what you said the platform was in data. And you can do cute things like you can only jump on a platform when it's green or something like that. As always, I recommend naming all of your graphical elements because eventually you're going to want to do something with them, and you need that name to grab a hold of them. Okay, show text. Look at all the stuff you have to import. You have to import text, but then you also have to import font, font weight, font posture. You're allowed to do tricks like this. If you don't want to do all these imports on their own, you do that, and it gets you everything in the text group. So JavaFX.scene.text, it will get you all the elements in the text group. You are allowed to do that. As a general rule, I don't do that because it brings in a lot of stuff that you're not going to use. And so you can get bloat in your code. But some people prefer that. That's a style choice. And if we look here, okay, text 1 equals new text. 2020, programming is fun. I'm not going to take responsibility for the quote. That's from the Liang text. 2020 though, what do you think that number is telling? Those numbers are telling you.
If I had to guess, is that the starting point of the upper part of the P
Right.
for programming is fun?
Right, it's the XY coordinate of that text, and it's good that you said it's the upper left hand point of the programming is fun. You know, programming is fun is the text that's going to be put inside of a bounding box, and that's going to be the upper left hand corner of the bounding box. Be aware of, you know, make sure you know what the positions mean. It's almost always the upper left hand corner of the GUI element that you're putting on the screen. Circles are the one exception because circles, their position is always set by the center point. So, you know, when you do the XY location of a circle, it's the center point. But when you do the XY location of an image or of a rectangle or of a text, it's generally the upper left-hand corner. That's the origin of that thing. Which means, you know, if you're doing movement, you have to take those kinds of things into account. So we make one text programming is fun, and then you have this text one set font, right, all this. This is just a annoying semantical issue, right? Syntactical issue, I should say. And how do you find out what the correct syntax is? That's where you go to the Oracle help pages. That's where you ask, you know, how do I set font weight in JavaFX? How do I make something italic in JavaFX? Can you do it to the text? Yeah. How do you do it? I don't know. Look it up on the Oracle help pages. The second one is just straightforward. Nothing's done to it. And then the third one, they change the text to red, they underline it, and they strike through it. And again, how do you know these things exist? That's what the help pages are for. All this stuff about set padding and new insets, these are giving you gaps between the graphical elements. You may or may not want them. You know, if you wanted to have a bunch of rectangles and you literally wanted them to join up together so the user couldn't tell they were separate rectangles, you probably don't want any gap at all. So we make the nodes, we make the pane, we add the nodes to the pane, and then we add the pane to the scene, add the scene to the stage and show. We just keep doing that over and over and over. That's the process, over and over and over. And when we run this thing, it shows what we thought it would show. The top one is bold and italic from line 29. The middle one isn't doing anything. Notice the /n is how you get a new line. That's the character code for new line. And then the third one is red, and it's underlined, and it's got the strike through. Notice the positioning, 2020, okay, that's 20 pixels over, 20 pixels down, 6060, that's 60 pixels over, 60 pixels down, 10-100, 10 pixels over, 100 pixels down. You can spend, and you probably will spend, a fair amount of time when you start putting a number of graphical elements on the screen, just getting things to line up. My recommendation for GUI is don't code, draw. Get a piece of paper, go to a whiteboard, lay out all your elements, get a rough idea of what you think the coordinates should be. Then you can code that up, compile it, run it, see how it looks, and you'll start fiddling with the coordinates for a while. And then you can spend, as you can expect, you know, you can spend far too much time trying to make it look just right with either fonts, colors, positions. But my advice when you're doing GUI stuff is always lay it out first, design first, then code. So you're going to lay it out on a whiteboard, or you're going to lay it out on some pieces of paper. Next, I think, is rectangle. Yeah. So if we do the rectangle, we get this thing. These little windows, man. So here's how this thing gets created. Let me do it this way. There we go. There we go. Okay. So in lines, I'm going to lose that again in a second. Window management. There we go. We create rectangle R1, and it's at, now here are 4 numbers again. 2510 is the position of the upper left-hand corner. 60 is the width of the base. 30, height. So we're saying it's at 2510, it's at 6030. And then set stroke, black, set fill, white. So that's why you've got black outline, white fill. Rectangle R2, they position at 2550. It's also 6030. Notice this, they don't do anything to the stroke or the fill, and it's all black. Remember, Java will default everything to 0, or what is considered 0 for whatever the data type is. And for a color, if everything is all zeros, it's black. If everything's at full scale, in RGB, that's 255, 255, 255, it's all white. And then R3 is a new rectangle they position, and then they show you, you can clip the ends. This arc width, arc height is rounding the ends. How would you know that you could do something like that? You look at examples. And then they build the pane and add the rectangles to the pane. Along the way, they add the text R1, R2, R3. And notice again how nicely it lines up on the screen. You know, you have to play around with that stuff. You have to figure out what the correct XY locations are going to be to make it look good. It's one of those things that it's not hard in terms of, gosh, I don't know how to solve this problem. It's not a situation like that. It's tedious because you probably have to do some iterations to get it to look the way you wanted it to look. And then they do this odd trick here in this loop. They build 4 rectangles. Rectangle R equals new rectangle, and they position it, then they rotate it, and then they do this random color. So each rectangle is actually a random color. And if we run this again, what do we have? Like a reddish color on the top. If I run it again, I have a, I don't know, more of a chartreuse color on the top. It's a different color. So I'm getting random colors for the edges of the rectangle. And then they add that thing to the pane. And here's what's interesting or odd about this particular way that they did it. They make a rectangle R and they add it to the pane, and then they make another rectangle R. So remember what R is. R is a handle to the memory space that contains all the information about this rectangle. So rectangle R goes to this memory space, and when you go through the loop and say rectangle R, now it goes to a new memory space because we said it's a new rectangle. Remember our discussion about how handles and objects work. So now R no longer has access to that old memory space. Well, if somebody doesn't have access to the old memory space, didn't that rectangle disappear? Well, no, because they gave that handle to the pane. So down here in line 49, they gave that handle to the pane. So the pane still knows where it is. Now, I do not recommend this. As I will say many times, if you have a GUI element and you probably in the future want to do something with it, and definitely if you know in the future you want to do something with it, I would give it its own name so that you can grab it later. You know, what if you want to take all those rectangles and have an animation where they're all rotating? you can't do it this way, or you can't do it very easily this way because they don't have a name. So you can't grab a hold of them and change their rotated value. Now, someone asked in the previous section, hey, even if I don't have the name, is there a way for me to still get a hold of that rectangle? And my answer is, yeah, I'm not sure how. I'm sure it can be done because I'm sure what you can do is go to the pane and basically query the pane and ask what its children are. You know, what do you contain? And it probably is in an array form. So rather than dealing directly with the array rectangle by its name, you have to go through the pane and deal with, you know, element number 6 or something like that, which is not, number one, it's not intuitive. Number two, you know, you're not going to remember what element number 6 was. So my recommendation is to give these things names. So I have gotta find it. My version is I make all these things attributes. And I recommend that, you know, for your GUI stuff, make everything an attribute. Why? What's the difference between an attribute and a value? What are the differences here? Does the same thing. I made the window a little bigger. So if I have a variable, where can I access that variable? You know, if I create a variable inside the start method, where can I access that variable?
Inside that start method.
Inside the start method and nowhere else, right? But almost certainly, remember how object-oriented coding works, you probably want to have other methods built that can deal with these rectangles. So if I make the rectangles as attributes, remember attributes are always available or accessible to all methods in the class. So if I make them attributes, I can make other methods that do things with those attributes, which means for now, I can clean up that start method. Remember my advice, don't do work in the main, don't do work in start. I violate that advice repeatedly in these examples, but that's the trick. Don't do work in main, don't do work in start. So instead what I do is I make little methods and I call the methods. So I have a method called make rectangles, a method called make rectangle array, a method called pane, and the one that says make rectangles is going to make rectangle 1, 2, and 3. Rectangle array will make those 4 rectangles that go in a circle there as an array of rectangles so I can grab them later, and then make pane with rectangles adds all those things to the pane. Now, if my start method is really small, and if I've named the methods well, it's really clear to the human reader what's going on here. And if the human reader needs to know the details of how the rectangles were created, they can go down to that method. So all I did, you know, you can see under make rectangles, I just cut and pasted the code that we had before. That's all I did. So keep in mind in object-oriented programming, what you want to do, you build these methods to do small little tasks. So this make rectangles method has a small task. Give me 3 rectangles. And make rectangle array, I just cut and pasted that loop down into here. I added it to an array, so I changed it a little bit. And it has a small little task, right? Make those 4 rectangles. And then make pane has a small little task, add that stuff. Okay, so that's my advice is, you know, keep these methods small and don't do the work in start, don't do the work in main, all of this construction. And as you get more complex GUIs, you know, this is pretty simple GUI. If you get more complex GUIs, this construction is going to be scores of lines of code. You know, it's not uncommon to have 60, 80, 100 lines of code just to build up your GUI. Well, you don't want all that crap in your start method. If people want to understand your program, what are they going to do? Oh, I'm going to go to the start method and see what see what happens. And if you get bogged down in all this, make a text, make a rectangle, make a text field, blah, 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 it's very difficult to figure out what's going on in the program. And so, again, I'm recommending that you do it more like this. By the way, I'm saying someone might come to look at this program. That person is you 2 weeks from now. You write it, and then 2 weeks from now, you need to go back. Oh, wait, what did I do here? Well, you know how that works. 2 weeks from now, 3 weeks from now, you're not going to remember the details of what you did at 1 a.m. in the morning. So you're writing partly for your own benefit, partly for others. As a rule, who are you writing for? Humans. You are not writing for the computer. You are writing for humans. So that's my soapbox speech about how to construct these things. Now, having said that, I don't do that consistently with all of these, because when I modified them from what the author did, I wasn't always having time to be consistent. No. All right. Let's see here. Now let's look at border pane, flow pane, image. Let's do show image. And all that does is show an image 3 times. And so images are kind of odd until you think about it from an object-oriented point of view. Remember when you wanted to get input from the console, you had to build a scanner, and the scanner served as the interface between the Java virtual machine and the operating system or the console? It's a similar thing here, and we're going to see the same thing when we talk about file I/O. An image is actually in memory in the machine, so you need some kind of a Java interface between these things. So you actually create the image, which is a file, you put that in an image object inside of Java. That has all the pre-built methods and attributes to do stuff to the image. And then in order to display it to the screen, you put it in an image view. It's a little more, intuitively, it's a little more complicated than it needs to be. But in terms of breaking down the separation of responsibilities, it makes perfect sense. When the more you work with object-oriented stuff, the more this makes sense. So that's what we're going to see here. And what did I do? Oh, I made the images, I made the views, image views, and then I made the pane. So I followed my advice and didn't do my work in the start class. I made all these images in the pane attributes. If you look at the Liang text, it is not done that way. So how do I make the image views? Oh, I make a new image. It's an image class, which is basically a container for the image file. But why would you need something like that? Why can't you work with the file directly? Well, that image class is going to give you the pre-built methods that Java provides for stuff you can do with an image. And then the image view contains that image. And we do that 3 times. And the first time it's just the image. The second time it's squished, right? 100 pixels by 100 pixels. The third time it's rotated. The author is just showing you stuff you can do with an image. You can do a whole lot more. What can you do? I don't know. If you can think of it, you can probably do it. How? I don't know. That's what Oracle help pages are for. They're quite good. By the way, notice where we got this thing. We got it from image/us.gif. Let's see, that's a file reference. Now, think about file references. If you're going to refer to a file, how do you do it, right? You can do something called a local reference or a global reference. The global reference starts at C drive, goes to wherever, whatever with the image name. You can put that in your code, or you can do a local reference. And what the local reference is this. It says, hey, if I don't tell you anything, that us.gif file, if I don't give you any other qualifiers, that us.gif file is right where you find the code. It's in the exact same places where you find the code. Or the way this is written, it's in an image folder, and then in that image folder is usgif. Well, where's the image folder? Again, if I don't give you any other information, look where the code is. And wherever the code is, you should find a folder or a folder called image. And inside that folder, is the US GIF. And sure enough, if I look in here, here's my whoa, I want to be careful. Global locator, right? CS225, modulo 7, that's where we are. That's the global. And then, but locally, I'm saying, look, if you look here, you should find an image folder. There it is. And inside the image folder is the us.gif, and it's down there somewhere. There it is, us.gif. Now, which do you think is better, using the global or the local?
Local.
Local, yes, use the local. And the reason is if you take your files and you move it to another machine, the global won't work anymore. Or if you happen to change something, the global won't work anymore. So use the local. By the way, this is also like when you install Java and it says, do you want to put me in the default location? In situations like that, you should say yes. And the reason is then you want to download something like Eclipse, or you might want to download another tool. And guess where Eclipse is going to look for Java? It's going to look in the default location. So you want, you don't want to mess around with this stuff. So use your local. Now, also Eclipse sometimes does weird things with that. One of the things that is good about Eclipse is it offloads work from you. It's really helpful. And one of the bad things is it offloads decisions from you. So it is going to put stuff in ways that are maybe not intuitive. So I've had students in the past where we're looking and it's like, well, we know the image reference is right, but the image is, I can't find the file, error keeps coming up. And that's because sometimes Eclipse is putting things in folders in a way that's not intuitive or, unexpected. So, you have to play around with that sometimes. It's a frustrating error to get because you know the image is there and Eclipse refuses to find it. All right, so what about this 100 by 100? Oh, that's squishing that one flag. And I always tell you guys, play around with this stuff. How small can I make it? What happens if I change it? You can. There it is, little tiny flag. Think of bad users. Think of, what can people do that's really going to screw you up? An image with negative size. It works. But what it works is, since the size made no sense, Java just defaulted to the standard image size. This is how you find out what Java behavior looks like, what the Java virtual machine does. This is how you find out what you can get away with it now. Is think of what we call the pathological cases. As engineers, you get good over time at thinking about these pathological cases. By the way, that whole thing with the image size, you can get real cute with that stuff. So several years ago, someone in their project was doing a demonstration of Hooke's law, and they had the image of a spring was just a bunch of lines, right? Looked like a seesaws of lines, and they had that in an image. And then when you compress the string and you drag the mouse, all they did was change the width of the image. And it looked like the spring was compressing, and the effect was really nice. It was a good effect because the way the image compresses, everything lined up. It just looked like a squished spring. So you can do cute stuff like that if you're in your project if you need to. I want to compile this one more time. There we go. Okay, so that's all the basic graphical objects, and now we get into the different panes. And if we look here, there we go, multiple kinds of panes. We've been using, for the most part, just good old pane. But there's several different types. This flow pane, we'll do it in this order. Flow pane, grid pane, border pane. Flow pane just lays everything out left to right. And then as you resize the window, you'll see it always makes sure that everything's visible. So if you make the window too narrow for what was laid out from left to right, it's going to roll those things down to the next row. And so as you're moving the size of the window around, it moves things. Now, sometimes that's good, right? Sometimes you want that to happen so the user has visibility into everything. Sometimes it's bad because you just spent 4 hours making this beautiful layout and then the user resizes the window and everything goes to hell. So it's a choice, it's application specific. So how do you fix that? Well, you can use the grid pane, and this is a nice way if you have stuff that needs to be in a nice orderly tabular form, the grid pane is there for you. And then the border pane is, I think almost everybody's going to use a border pane in their project. It divides the screen up into different areas, and you're kind of seeing an example of it here while you're looking at PowerPoint, which I doubt is written in Java, but it's basically a pane type system. You see where the big slide is, would be the center of the border pane, and then off to the left where the slide sorter is, or where the slide summary views are, that's the left of the border pane. The ribbon on the top is in the top of the border pane, right? So what the border pane allows you to do is do what most applications do, which is provide the user with the vision of what's happening in the center, and then on the left or the top or the bottom, providing all the navigation or the controls or the summary information. You know, that's a common way that things are laid out. If you've ever taken an HTML class or two, you know, that's a normal way to lay out web pages. And it's a normal way to lay out applications like this. So let's walk through those panes pretty quickly. And then what's going to happen next week is we're going to get into user interactions and animations and things like that. So the examples get a little bit meatier. All right, if we do flow pane, this is straight from the author. I did not change this. They build a flow pane, and then they do this padding and H-gap and V-gap. That's all about the spacing that you want between the elements. So each element has a bounding box. That bounding box has padding. So from the edge of the actual element to the edge of the bounding box, and then the gaps between the bounding boxes. And they do this new label, new text field, new label, new text field, right? They're adding all this stuff to the pane without naming them, because this again is just an example of how things flow in a flow pane. But again, I cannot stress it enough. My recommendation, especially with a text field, is to name those suckers, because why do you put a text field on there? You want the user to input data. And how are you going to get that data if you don't know the name of the text field? It can be done, but it's easiest just to do it this way. So if we show the flow pane, there it is. And the reason it's called the flow pane, see if I change this, it just lays things out left to right until it runs out of space horizontally, and then it, you know, line feeds and goes to the next line, which is fine if that's what you want. But if you spend a lot of time making a beautiful layout and then the user starts changing the size of your window, then not so fine. You can lock the sizes of windows, as you would expect, right? Okay, so that's that guy. So how do you fix that? You do the grid pane. Oh, so much better. And I want to check and see if I did anything odd here. Nothing special. Okay, grid pane. All right, so with the grid pane, they are making effectively the same thing. But look at that, it stays nice, ordered. Whenever you do anything that's tabular, grid pane's not a bad idea. You can do, physically setting the X and Y locations of everything. That works too. All right, so they make a grid pane. They set the alignment to be positioned in the center, so that's why it keeps staying centered even when I resize the window. And then they do all this, padding and gapping so that there's this space between the elements. And then they add this label first name, add a text field. And again, they don't name the text field. So, how are you going to get data out of that? It's more difficult. But the bottom line is they're adding these things one at a time. Now, when they add them to the grid pane, you don't just add them, you have to say where you want them. So we have 0, 0, right? The first name is up there in 0, 0. Okay, so what do you think? It's a grid. Think of it as a matrix, right? How do you reference an element in a matrix, right? Don't you do element 1, 2, element 5, 7, that kind of thing? And what does it mean? Like in a matrix, if I said, or in a table, if I said 3, 5, am I talking about the third row, fifth column, or am I talking about the third column, fifth row? In algebra, like in matrices, or in when you're dealing with tables in virtually every field.
Be third column, fifth row.
Yeah. Okay. It turns out, yeah, almost everywhere it's row column. Almost everywhere it would be third row, fifth column. In JavaFX, it's column row. So 0, 0 is the 0th column, 0th row, and then text field 1, 0 is the 1 column, 0th row. And sure enough, where my cursor is flashing there, that's that text field. And then label middle initial is the 0 column, first row. The next field, the next one is, can I tap through here? Yeah, that one is first column, first row. Then the text for last name or the label for last name is 0 column, second row. And here we are in 1 column, second row. And then for the button, they put it in the first column, third row. Notice there's no 0th column for third row. That's okay. It's just an empty cell in the grid. And as usual, our buttons don't do anything yet. We're going to fix that next week, right? We're going to tie behavior to buttons next week, but not right now. But this example proves my point. I keep saying you should name these things because because you want to do something with them, you need to have access to them with the name. And look what they did. They wanted to position the button over to the right to make it look good, and it does look good. But because they wanted to first build the button and then position the button inside that grid, they needed to access that button, so they named it. Button BT add equals new button. So name all your GUI elements, and I would make them attributes. Now, notice the name of the button is BT add. That's a good mnemonic to remember, right? All your buttons should start out with BT or whatever your mnemonic likes, but BT is used, by a number of people. Text fields, TF. Like if those 3 text fields, if I named them, I'd probably call it TF first name, TF middle initial, TF last name, or TF first, TF MI, TF last. So I know right off the bat when I'm looking at the code, oh, that's a text field. What does it do? Oh, it looks like it's the middle initial. If it's TF1, TF2, TF3, and you've got 30 of those, you're not going to remember what their job is. You're not going to remember what data they hold. All right, so this is, column row. It does not flow. And by the way, these are functional. They do stuff. I can't get that data out of there, but I can put data in there. So because it's object oriented, that text field came to you as an object. It already has functionality. It's your job to make whatever the user puts in there get to your software so it can be useful to you. Grid pane 2, do we care what that is? I don't think we care what that is. Some of these I messed around with in previous semesters and I added the number on it. Okay, now let's look at, there's flow pane, flow pane, flow pane. I want to show the border pane, which is going to be an important one. Almost everybody in your project will use a border pane. And like I said, they love these tiny little windows. I know. So that's the border pane. And what they're showing you is the border pane is composed of these 5 elements, the top, left, center, right, bottom. And in each one of those, typically what you do, you actually build another pane and put it in there. So like on the top, if you wanted a bunch of controls, you could build a pane with all the controls and put it inside the border pane. So, you know, notice this nesting doll thing, right? You can keep nesting panes inside of panes inside of panes. That's a common thing to do. Or next week, like for a lot of games, initially you have a splash screen, welcome to the game, right? And then a button that says start the game. And then it moves to another screen. Or in between games, if you have 5 levels, once the player completes a level, you go to a new level. Well, the border pane is an easy way to do that. You make your welcome screen as a pane, welcome pane, and you do border pane, set, center, welcome pane, and there it is. And if you don't put anything in the left, right, top, or bottom, they go away. So the whole thing will be the center. And then once you click start game, you have level 1 pane. And so you say border pane dot set center level 1 pane, and it'll just replace that pane inside the center. And so the user gets a new screen. And if they complete that level, guess what you do? Set center level 2, set center level 3, and it just keeps going and changing the scenes, not the scenes, because technically that's a different thing. Changing what the user views, because it's changing the panes out. It's an easy trick. Many of you will actually use like the left and the center, so that you've got on the left maybe some controls or some informational stuff. You know, you want to show the user's health, the player's health status during the game. Oh, okay. You can have a health bar on the left-hand side, and that way it's not overlaid on top of the gameplay. So it's a pretty helpful form of pane. Now, having said that, as always, the Liang text gives us bad code. So they build a pane, right? Border pane, pane equals new pane, no problem there. And then the way you put other panes inside is with this set top, right? Set top puts it in the top, set right puts it on the right, set bottom right. So you're going to do that set center when you want to just go from scene to scene, set center. And they do an odd thing. They build, you know, they have to have you have to build a pane to put in there. So they build something called a custom pane. And notice they don't give it a name. I would name it so that I can put it in and take it out, right? And they do this thing called new custom pane quote top. And all they're doing is making stupid simple panes, which is exactly what they should do for the demo, where it just contains the word top, center, left, right. But it's a custom pane. Well, what the heck is a custom pane? If you look through the kind of panes that Java gives you, there is no custom pane. Well, they built it. They built a custom pane. And there they committed a horrible sin. So they actually have a new class custom pane extend stack pane. Now stack pane is a pane that Java gives you. I rarely use them. They stack things one on top of the other. So anyway, they create a thing called custom pane, and all they do is they put the word of, you know, whatever you told it, top, right, bottom, center, in the middle of the pane. That's all they do. So they're building a stupid simple pane so that they have panes to shove into the border pane. But they actually built it as a separate class here, custom pane, extend stack pane, and then they define the class. And they do it inside the show border pane.java file. So this is a great example of what you should never, ever, ever, ever do. Do not put classes inside. You can put multiple classes inside of a class file. Don't do it ever. There's very, very difficult to come up with any kind of a rationale as to why that would be a good idea. If you have a class, then clearly that means that that class was important to whatever you're building, and it needs to have its own file. So they should have had a custom pane.java file, and then they could have used the custom pane here. So when I get this far where I refactor this code from the author, I'll make that change. So just be aware that there's a couple lessons there. One is the actual border pane itself. It's very handy. It's a great thing. And the other is this is really bad coding practice. And I think it's unfair to give that to a student as an example of what to do in a textbook. So I'm going to warn you not to do that. And like I said, if you have a class, give it its own file. Part of that is again, we're always thinking about how your software might change in the future. And I don't mean 3 weeks from now, I mean 3 years from now or 10 years from now. You don't know if that class will be used by other classes, right? You're thinking, oh, I'm going to put it here because no one will ever use this. Well, you don't know. So that's border pane. And then we have time here. I can show the H box and V box. The H box, V box, where is it? Where does it show H box, V box? Guess what H box is? It's a kind of a pane. Guess what H stands for, and guess what V stands for? H is for a vertical, and a V box lays things out vertically. I'm sorry, H box lays things out horizontally, V box lays things out vertically. So what we've got here are two panes. The one on the top is in H box, and it's laying out computer science, chemistry, American flag, interesting mix from left to right. And then down below we have a V box, and so it's laying out courses from top to bottom. And buttons work, but we didn't do anything with them. Now, I've got two panes inside of another pane. One is an H box and one is a V box. What pane would I like to see that be put into, do you think? And I can't remember if they did it or not this way. I would like to see them in a border pane. So when I look at the code, I'm hoping I see a border pane. Hey, what do you know? There's a border pane. So they build a border pane. And in the top, what do you know? They actually did this with small methods, right? I didn't change this. They built an H box and they put it in the top. They put it in the V box and they put it in the left. And the H box, V box is down here. Get H box and get V box. I would have called them make because you're not getting them, you're making them, but oh well, that's style. And so that's the code for that. I'm going to say virtually everyone will use a border pane for your project. And of the other panes, the people who are playing games will probably use an H box or a V box for their status type stuff or navigation. And people who are doing a lot of data entry stuff are going to use grid panes to set up the text fields and labels in an attractive way. That's my experience of how these things normally go. So you have all this code, play with it, mess around with it, and do weird stuff to it and try to break it, right? And then try to fix it. Try to understand why it broke and why it worked. Do we have questions real quick before we go? We're at time.
Professor, for the images, are you saying to make them local, you could just put an image folder inside of your CS225 workplace?
Yes.
Okay, and you could take a picture with your phone and then just import that picture in that folder, and you could upload it in your GUI?
Yes. And then you just always have to be careful where if you manually put it in, you know where it is. If you let Eclipse put it in, sometimes weird things happen.
Okay, I got you. Thank you.
Other than that, you're exactly right. You know, wherever your code is, you can put a folder right there with that code and put all your image files in there. In fact, some of you guys are using data files, and I would say, yeah, someone's asking about showing videos inside of Java. Yeah, it's a Java media player, I think, and it's easily done. It's easy when it works, right? You know how software is. When it works, it's easy. Yeah. Some of you guys are doing data files, and you have you would recommend having a separate data folder inside. You know, here's all your source code and a data folder, and all your file IO goes to that. You know, for some of you guys that are saving a lot and retrieving a lot. Okay, other questions? All right, see you Friday.